Good morning, ma'am. This is G. Baba Sohel. I am from second CSC A section. My topic is about chromatic number decision problem. Into the topic, title of this slide: Chromatic number decision problem explanation. Introduction to graphs. A graphs consisting of vertices, nodes, and edges connections. Graphs are used to model pairwise relationships. Understanding graphs is essential for grasping the chromatic number problem. What is a proper coloring? A proper coloring assigns colors to vertices so that no adjacent vertices share the same color. Proper coloring helps in resource allocation problems like scheduling. The goal is minimize the number of colors used in coloring. Chromatic number definition. Chromatic number of a graph is the smallest number of colors needed for a proper coloring. It indicates how complex graph structure in its terms of coloring. Finding the chromatic number is a fundamental problem in graph theory. Decision problem in graph coloring. The chromatic number decision problem asks whether a graph can be colored with at most k colors. It is yes or no question. Can the graph can be colored with k colors? This is the decision problem is crucial for understanding computational complexity. Importance of the decision problem. It simplifies the problem of finding the exact chromatic number. It is used in algorithms, computational complexity theory. Solving it helps in various applications like scheduling, register allocation, etc. Complexity class of the problem. The chromatic number decision problem NP complete for k greater than or equals to 3. NP complete problems are believed to have efficient solution. This classification implies the problem in computationally challenging for large graph. Why is it NP complete? Directions from the known NP complete problems can transform instances into graphs coloring problems. The difficulty lies in verifying solutions, not in finding them. This makes it benchmark from computational complexity research. Example graph introduction. Consider a simple graph with four vertices and some edges. The structure of the graph influences its chromatic number. Let's analyze this graph, understand the decision problem better. Example graph illustration. Vertices A, B, C, D. Edges A, B, B, C, C, D, D, A, and AC. This graph resembles a square with a diagonal. Can the graph be two colorable? Attempt to color verticals with only two colors. Check if any adjacent vertices share the same. In this case, it is not possible, so the answer is no. Testing three colorability. Try to color the graph with three colors. Assign colors systematically to avoid conflicts. It can successfully three colored, so the answer is yes. Conclusion. On k is equals to 2 and k is equals to 3, the graph cannot be two colored but colored 3 colored. Therefore, the chromatic number of this graph is 3. That is a problem for k is equals to 3 yields yes. Implications of examples demonstrates the how decision problem accessible, feasible coloring options. So the importance of systematic testing for difference k highlights the computational difficulty for larger graphs. Practical applications of graph coloring. Scheduling problems like exams and job assignments. Frequency assignment in wireless network. Register allocation in compiler optimization. Challenges and open problems. Finding exact chromatic number for large complex graph remains difficult. Approximation of algorithms provide a near optimal solutions. Ongoing research aims to identify special graph classes with an efficient solutions. Summary of these key points. The chromatic number decision problem asks if graph can be colored with k colors. It NP complete k greater than or equals to 3 indicating high computational complexity. Example illustrates how the problem is approached with small graphs. Thank you. Thank you ma'am for this opportunity.